If you just got notice that you tested positive for a serious disease, take a breath. Don't immediately panic. If someone told you that the test is 90% accurate, it may feel like you have a 90% chance of being sick, but that's not how probability works. This app and video are educational. It's not a diagnosis and it's not medical advice. I'm not telling you to ignore a positive result. I'm trying to help you understand what a positive result might mean. Here's the question that matters. Not how accurate is the test, but given that I tested positive, what's the actual chance that I have the disease? Those sound like the same thing. They're not, and the difference can be huge. Imagine that we're dealing with a population of 100,000 people, as shown in this app. Suppose the disease affects about 1% of these people, as shown by the first slider. So 1,000 people are actually diseased and 99,000 are healthy. Now imagine a test that's 90% accurate, as shown by the second slider. In this model, that means if you have the disease, the test catches it 90% of the time. If you don't, the test correctly says that you're healthy 90% of the time. So of the 1,000 diseased people, about 900 test positive. Add those up. 10,800 people get a positive result. Only about 900 of them actually have the disease. So if you're one of the people that tested positive, your chance of actually being diseased is only 900 out of 10,800, which is 8%. The probability that you're sick is not 90%, it's only 8%. When a disease is uncommon, even a pretty good test can generate more false alarms than true detections, simply because there are so many healthy people in the pool. This is Bayes' theorem in plain language. It says, take what you already know about how common the disease is, the base rate or prevalence, and update that with the evidence from the test. What you want is not probability of a positive test given that you're sick. What you want is probability that you're sick if the test is positive. Those are different numbers. Mixing them up is one of the most common and most frightening mistakes people make when getting results like this. I built this free interactive visualization called Medical Testing and Bayes' Theorem so you can see how it works for yourself. There's a link in the description. The app answers the question, how worried should you be if you tested positive? There are two sliders. One is disease prevalence, which is how common the disease is in the overall population. The other is test accuracy, which represents both sensitivity and specificity. They're set to the same thing. As you move the sliders, three things update live. Bayes' formula with the real numbers plugged in, calculating the actual chance that you're infected. A Sankey diagram dividing the population into diseased versus healthy, then flowing into test positive and test negative. A Venn diagram showing how much the diseased group and the test positive group overlap. Hover on the flows and regions and you'll see true positives, true negatives, false positives, and false negatives highlighted. Drag prevalence down and watch the probability drop. Drag accuracy up toward near perfect and watch it climb. A positive test is information, not a final verdict, especially for rarer diseases. You often need a confirmatory test or clinical follow-up. If you think this app could help someone understand an alarming test result, share it with them.